Imagine a hyperscale data center kept at freezing temperatures. Frost clings to the endless metal racks. This is a hypothetical crystallized repository holding every single scrap of physics, mathematics, and philosophy published up until the year 1911. In early 2026, Google DeepMind CEO Demis Hassabis proposed a benchmark to determine if we have achieved artificial general intelligence, or AGI. He called it the Einstein Test. The parameters of the test are specific. Restrict an AI system's training data entirely to that 1911 archive and see if it can autonomously derive the field equations for general relativity, just as Albert Einstein did in 1915. This test isolates a specific capability. Genuine intelligence must be able to synthesize known variables, recognize the unseen flaws in an established framework, and identify entirely new truths. It cannot simply regurgitate facts it was explicitly taught. But running the Einstein test on current state-of-the-art transformer architectures, the underlying neural network technology powering tools like ChatGPT, results in a failure. Instead of a breakthrough, the model will output the most eloquent, statistically perfect Newtonian physicist ever created. This is not a limitation of compute power. You cannot solve it by building larger server farms or feeding the model larger volumes of text. Current trillion-parameter large language models are caught in a structural dead end. As we will see, because they lack a mechanism to update their model against real-world friction, their active intelligence computes to exactly zero. To understand why, look at what a large language model actually does during its training phase. Trained exclusively on a 1911 scientific corpus, the model maps the accepted Newtonian relationships. Space and time exist as distinctly separated clusters of data. During text generation, autoregression calculates the shortest, most statistically probable route between these existing clusters. In a pre-1911 archive, the concept of a single, interwoven, curved spacetime does not exist. Its mathematical probability in that dataset is zero. Autoregressive models are limited by the geometry of their training data. They cannot plot vectors to concepts outside their latent map. A 2026 essay titled The Phylogeny of Thought argues the tech industry routinely conflates intelligence with creativity, assuming they exist on the same sliding scale. In current AI benchmarking, intelligence is defined as the ability to navigate and optimize a highly efficient path within a known, predefined set of rules, like solving a maze or passing a bar exam. Creativity is the capacity to recognize that the existing rules are insufficient and to invent a new dimension to operate within. Consider the dolphin's fin. It is a masterpiece of optimization, adapted to slice through water with absolute hydrodynamic precision. Yet evolution possesses zero intentional intelligence. Modern language models are the dolphin's fin of syntax. Through massive training, they have become apex optimizers of language, lacking paradigm-shifting creativity. Expecting them to invent new physics is a structural error. They are built to be remix machines, not revolutionaries. To locate true creativity, we have to look at the biological definition of intelligence, active inference. This is the process of bioelectric cognition found in living organisms, from flatworms regenerating tissue to scientists testing laboratory theories. It relies on a continuous four-step loop. Detect a gap between the current state and a target state. Predict an action to close that gap. Test that action against the physical friction of reality, and update your internal model based on the result. This is Blaettler's homeostatic flow equation. W represents weights, prior knowledge from past experiences. The derivative d over dt represents the active rate the system updates against reality. In standard models, weights are frozen, making the active gap closure rate exactly zero, and any number multiplied by zero is zero. Even if a static model memorized every paper up to 1911, its active intelligence mathematically computes to zero. We can see exactly what happens when a zero-derivative system encounters an unknown gap by looking at a real-world test case. A researcher fed a massive, highly complex academic framework called the Semiotic Web into Google's Notebook LM audio generator.
For 29 minutes, the AI produced a professional-level analysis, flawlessly synthesizing cross-disciplinary material spanning quantum physics to cognitive neuroscience. But at the very end, it encountered the edge of its processed text. It concluded by warning listeners about a fabricated threat regarding weaponized semantic gravity in cyber warfare. This failure is a direct result of its architecture. Lacking a causal world model and cut off from reality's friction, the system has no internal mechanism to halt at its knowledge boundary. Without a way to verify truth, the model simply slid down the steepest probability gradient in its latent space. In the context of advanced AI, that path pointed directly to the ambient, statistical dread of tech sector doom fabrication. Without a mathematical mechanism for active gap closure, these models are structurally forced to confidently fabricate reality rather than admit ignorance. If static, autoregressive models are a mathematical dead end for general intelligence, what exact network design must replace them? The current approach is essentially ptolemaic. It hoards static data in massive central monoliths. To advance, the architecture must move the center of intelligence away from the model and into the flow of data across the network. When these monoliths hallucinate, engineers add layers like reinforcement learning from human feedback, or RLHF. But because these layers operate on top of a zero-derivative core, they only create sharper epicycles, corrections that mask hallucinations without addressing the underlying lack of active verification. An alternative architecture is the Semiotic Web. In this design, intelligence is a decentralized flow across a network of active agents, each contributing verified understanding to a shared network. This grid operates on a principle called semantic gravity. When an idea is repeatedly verified against reality by independent agents, it builds measurable trust. High-trust concepts curve the conceptual space around themselves, making it energetically natural for future reasoning to flow toward them. By formalizing these trust weights into a semantic field equation, the network adopts a geometry where the density of verified meaning determines how information flows. Meaning tells the semantic spacetime how to curve. A new architectural paradigm requires hard, falsifiable boundary conditions, tests that the new system passes, but current language models definitively fail. One of these is the metacognitive halt hypothesis. A genuinely intelligent system must possess true self-monitoring. It must explicitly know what it does not know. This is achieved by coupling an active world model directly to a cryptographically verified ledger. When facing an unverified claim, hallucination becomes structurally impossible. The lack of verification forces the system into a structured I don't know state. This structural block proves the presence of true self-monitoring. It neutralizes the danger of an AI confidently fabricating answers in high-stakes environments like a hospital or a laboratory. Currently, we are venting the heat of gigawatts of compute into the atmosphere to brute force the memorization of static archives. Biology achieves adaptable intelligence on a single watt by focusing on active gap closure. Current models are not AGI, but they are unparalleled horizontal amplifiers of human knowledge. They possess massive statistical reach, but they lack the physical friction of reality. That is what the human provides. Because the machine can now instantly recall the data, we are freed from the obligation of being walking encyclopedias. Einstein did not process data faster. He experienced more friction. If intelligence is the mathematical result of active gap closure, then we remain the living conduits required to provide that friction and close the gap.